Hi, and welcome to the second part of the vacuum tube Tesla coil build. So there's quite a few things I haven't covered in the previous episode, because that video was made in kind of a rush. So now let's look into it. Okay, so here you can see the photos of how the design evolved. Now it looks something like this. As you can see, there's a feed-through from the secondary to the breakout point located on an insulator. That's because I didn't want any metal parts sticking into the secondary tube, which could arc internally. Sadly, that didn't save me from an actual arc inside of the secondary. As you can see, I had to cut off the top of it and of the sleeve that it's put inside to better insulate it. So that led me down a long rabbit hole of adding multiple layers of insulation onto it. But that has made it completely arc overproof, hopefully anyway. At that point though, my tube started acting up. The joints from the bulb to the actual socket of the tube were corroded. One of them somehow welded itself to it, so I couldn't just take it off. I had to poke at it with my screwdrivers through these little holes, which took ages, but luckily I managed to actually make it contact pretty decently. But then the machine blew up. First, the level shifter setup. This is the rectifier, the diodes, and the filter caps. You can see that there are two strings of 4 diodes, each connected in parallel. Those diodes are rated 5 kV 3 amps. And the capacitors are just Russian ceramic caps for filtering. Now the capacitor that stores all the energy, those are just 5 microwave oven capacitors connected in parallel. And the whole setup looks something like this when connected. Eventually I decided to space things out a little bit more because I was afraid that there would be an arc from the diodes to the body of the capacitors, which are metal in the end, but here you can roughly see how it looked. Here's the whole thing connected up with the grid leak circuit and stuff. As you can see, it's kind of crammed. There's a lot of mess with the wiring, but it's fine. This big rotary switch is quite a score, but as I said, this whole idea of adjustable grid leak was kind of a mistake. So time for a test. As you can hear, it's getting really loud when the power goes up. Alright, so I've changed a few things since that test. As you can see, the grid leak switch has been completely removed, and these are all the parts for the grid leak. It's just lying in here as I didn't find time to put it all together yet. But I will be reducing the size of the grid leak in hopes of making this a little bit more simple, less messy, and just better. Improving the design, as the previous one was a naive one. I cut down the amount of turns on the primary significantly, as I think that the more turns was not necessary and it was reducing the frequency, which is not that bad in itself, but I just thought that this might help. And I made taps for the feedback coil and I've moved them apart, as the loudness of the arcs I think was coming from the fact that this was just too closely coupled to this. So spacing them out a little bit more will help with that probably. Also, I've kind of improved the design on the connections here. As you can see, this is all properly insulated now, and there's just a sharpened point at the screw itself. There's no additional wire that's sharpened, that's sticking out. I hope to buy a new toroid for this soon, so this will further improve the looks and just the looks, and it will of course significantly hurt my pocket and reduce the total amount of money I possess, but you know, just for this to look nice is quite a cool thing. Anyway, another thing I changed is the transformer. Now you can see it's 2 MOTs in parallel, both primaries and secondaries, and the rest's pretty much the same. But thing is, the old transformer, I spotted that there was a significant spot on the coil that looked like it was heated. So probably what happened is an arc over happened inside of the secondary of the transformer, and these caps discharged through that, making the loud bang that we've heard in the recording I played a while ago. So I think that this should help. Anyway, thing is, we've seen both arcs inside the tube, and a flashover happened inside of the previous transformer, which means somehow that there's a huge voltage inside this system once I power it past a certain moment. I don't want to mess anything more up because it's been quite an expensive journey just to break, a tube and then the transformer, and I don't want to waste more parts. So I'm trying to figure out what made the surges in voltage. You can follow that on High Voltage Forum, but I sadly have put this project on a bit of a halt as I'm trying to figure out what went wrong. So yeah, that would be it for this update video. Sorry if it was a bit anticlimactic, not much of sparks and more of just rambling, but I've got to figure this problem out, otherwise this thing is pretty much a pile of trash. A nice looking, but still just a pile of trash. It can't do, it's the thing it's been made to do. So yeah, let's hope I get this to work soon. Thanks for watching.